In this video, we're going to learn about data warehouses. So data can be operational or analytical. Operational data is exactly what it sounds like. It's data that's produced by your organization's day-to-day operations. The data is volatile, meaning it's in memory, and very detailed. Analytical data is used to make business decisions as opposed to recording the data from actual operational business processes. The data is detailed and could be a summary or history of data, and the scope can be company-wide. A data warehouse is a type of database that's optimized for analytics. A data warehouse is a type of database that's optimized for analytics rather than business operations. A data mart is a subset of a data warehouse, and it's usually oriented to a specific business line or team. There's a three-step process called extract, transform, load, or ETL, which extracts the data from different source systems. Then it transforms the data, kind of like applying calculations or concatenations and so on. And then it finally loads the data into the data warehouse system. So extract, it retrieves raw data from an unstructured data pool, and then it migrates it into a temporary staging data repository. And then transform, also called clean sometimes, and then in the transform step, it cleans the data extracted from the unstructured data pool, ensures that the quality of the data is good prior to the transformation, and then it structures and converts the data to match the correct target source. And then step 3, load. So it loads the structured data into the data warehouse so that it can be properly analyzed and used. There are also Etl tools that companies use to help make this process easier. Examples of the tool include Power Center, SQL Server integration services, or Oracle Data Integrator. So let's now talk about the database warehouse design. So a star schema, showed in the upper right-hand corner, is a modeling approach that's widely adopted by relational data warehouses. It makes analytic queries easier, and it requires modelers to classify their model tables as either dimension or fact. The fact table, shown right in the middle of the star, stores observations or events, and it can be sales orders, stock balances, exchange rates, temperatures, etc. A fact table contains dimension key columns that relate to dimension tables and numeric measure columns. And dimension tables describe the business entities, and it's a structure that categorizes facts and measures in order to enable users to answer business questions. The primary key of a fact table is the composite of all foreign keys referencing dimension tables. Dimension hierarchies organize data at various levels, and it shows relationships are represented graphically in a collapsible hierarchy diagram. Like this car hierarchy shown here on the bottom right corner. The levels below the database name are dimensions, and the levels below each dimension are members. Historically, data needs to also track the date and time. The date dimension table is for the day, and the time dimension table is for the time in minutes. And in a fact table, foreign keys establish the date and or the time. Fact tables contain foreign keys start date ID and end date ID for referencing date and time dimensions. To establish the time of a fact, The end date ID for a current row is set to some time much further in the future until the real time is set. This method of adding start and end times to a fact table as a foreign key is called the Type 2 design for slowly changing dimensions.